This is example 5 of chapter 11. Find the current at time t in the circuit shown on page 6. If resistance is 2 ohms, inductance is 1 Henry, capacitor is 0.5 farad, and the voltage is 2 cosine 2t. With the initial condition, current initially is 0, and the rate of change of current is also 0. Hence, find the transient and steady state current. So let's draw the circuit first. The circuit is shown here where the voltage is 2 cosine 2t and the resistance is 2 ohms. The inductance is 1 Henry and the capacitance is 0.5 farad. Based on page 11.6 lecture notes, the equation of circuit is L d2i dt square plus R di dt plus 1 over Ci equal to the rate of change of E at time t. So E prime t. Substituting all the parameters, then we get L, we have already seen that is 1 Henry, resistance is 2 ohms, capacitor is 0.5 farad, and E is 2 cosine 2t. You get d2i dt square plus 2 di dt plus 2i, because 1 over 0.5 is 2, equal to differentiation of 2 cosine 2t. But what is differentiation of 2 cosine 2t? Differentiate cosine 2t is minus 2 sine 2t. So this is equal to minus 4 sine 2t. Together with the initial condition, the current at time 0 is 0, and rate of change of current also is 0 in the beginning. So how to solve this initial value problem? You take Laplace transform of each term, then you find that Laplace transform of d2i dt square plus 2 Laplace transform of di dt plus 2 Laplace transform of I equal to minus 4 Laplace transform of sine 2t. Using the formula card, Laplace transform of d2i dt square is s square Laplace transform of I minus s current at I0 minus I prime 0. And then Laplace transform of di dt is s Laplace transform of I minus value of current at 0, and the third term leave it alone. And the Laplace transform of sine 2t is 2 over s squared plus 2 squared. Putting in the initial value of current and rate of change of current, then they are all 0. So combining the Laplace transform together on the left hand side, you get s squared times Laplace transform I plus 2s times Laplace transform I and plus 2 times Laplace transform I here equal to minus 8 over s squared plus 4. And factor out Laplace transform I, then you get s squared plus 2s plus 2 times Laplace transform I equal to minus 8 over s squared plus 4. And so Laplace transform I is equal to minus 8 over s squared plus 4 over s squared plus 2s plus 2. Then, how do you find I now? We need to do partial fraction. So, let's say Laplace transform I is as plus b over s squared plus 4 plus cs plus d over s squared plus 2s plus 2. We are going to compare the coefficient. So, minus 8 is equal to as plus b times s squared plus 2s plus 2 plus cs plus d times s squared plus 4. Then we compare coefficient of s cubed, s squared, s power 1 and constant. To compare coefficient of s cubed, first of all, where the s cubed is, on the left hand side, there is no s cubed. On the right hand side, you get as times s squared, you get as cubed. Cs times s squared, you get cs cubed. So this is the first equation. Then compare s squared. Left hand side, there is no s squared. Right hand side, there is a as times 2s, you get 2a s squared, b times s squared, d times s squared. Then compare s now. Left hand side, there is no s. Right hand side, have 2as plus 2bs plus 4cs. Finally, compare the constant. Left hand side is minus 8. Right hand side I have 2 times b plus 4 times d. So we have 4 equations for unknown. Let's look at how to resolve them. So for this 4 equation, I look at the first equation, c equal to minus a. I will eliminate c. Okay, so c will be replaced by minus a. So all the c are here. Okay, c equal to minus a. So all the c will be replaced. So for example, the third equation, I have a c there. So this c will be replaced by minus a. So let's look at the elimination process. So second equation, no change because there is no c, right? But third equation, here 2a plus 2b plus 4c equal to 0, where c is replaced by minus a now. So that will give me eventually 2a minus 4a equal minus 2a plus 2b equals 0, and so minus a plus b equals 0. And the fourth equation will not change because there is no c there, but you can simplify this as divide everything by 2, you get b plus 2d equal to minus 4. So these three equations has no c inside there because I have eliminated c already. Only have a, b, and d. Next, based on these three equations, based on these three equations, I choose the easiest one. Let's say I choose equation 3. Equation 3 say that b is equal to a. Then I eliminate b. So choose a. Now I want to eliminate using the third equation to eliminate b. So b is equal to a now. So the second equation, b is equal to a now. So 2a plus a, right? B is equal to a here. So change the b to a now. So we get 2a plus d equal to 0. That means 3a plus d equals 0. And the fourth equation, b is equal to a now. So a plus 2d equal to minus 4. Then eventually I have two equations with only two unknown A and D. There is no more B and C. What is next is I try to eliminate D now. D is equal to minus 3A. So if D equal to minus 3A, so the fourth equation becomes A plus 2D. D become minus 3A now. Okay. So equal to minus 4. So that gives you minus 5A equal to minus 4, or A equal to 4 over 5. Once you get A equal to 4 over 5, then my C and B and D will come out already, because C equal to minus A, B equal to A, D equal to minus 3A. So C equal to minus A equal to minus 4 over 5, B equal to A equal to 4 over 5, D equal to minus 3A becomes minus 12 over 5. So we go back to the partial fraction. A is 4 over 5, B is 4 over 5, C is minus 4 over 5, and D is equal to minus 12 over 5. Now what's next? So we do the inverse Laplace transform now. So I is the inverse Laplace transform of first term. When you factor out 4 over 5, factor out 4 over 5, get inverse Laplace transform of s plus 1 over s squared plus 4. Second term, you can also factor out minus 4 over 5, you get s plus 3 over s squared plus 2s plus 2. Okay, then you can split the first term. So get 4 over 5 inverse Laplace transform of s over s squared plus 4. Okay, and then the second term actually is 1 over s squared plus 4. But you purposely times 2 and then divide by 2. So that the second term will give you sine 2t. And then the last term, minus 4 over 5, inverse Laplace transform of s plus 3 over s squared plus 2s plus 2. S squared plus 2s plus 2, you can complete the square, become s plus 1 squared plus 1. Okay, now adjust the numerator, the denominator, and numerator has a copy of s plus 1. So you adjust the numerator, become s plus 3 become s plus 1 plus 2. Okay, s plus 3 become s plus 1 plus 2, and now apply the first shift. You're shifting s plus 1 to s. So because you're shifting s plus 1 to s, so you have a multiplied by e power minus t now. So this will become multiplied by e power minus t, s plus 2 over s squared plus 1. And then you split the numerator now and take inverse Laplace transform. So this will be equal to cosine t plus 2 sine t. And this is the final answer for the current. We are going to explore what this means. The current is a sum of two solutions. There are two portions of the solution. One is the steady state solution. Okay, steady state solution is actually this one. This is a solution, you always stay there. And then there is another solution called the transient state solution. This solution will converge to zero. It eventually goes to zero. Okay, it goes to 0 eventually. This is because e power minus t goes to 0 as t goes to infinity. We are using the graph decimal to demonstrate how the solution looks like. This is an illustration using decimal. You can look at the website and try it yourself. I have set the x-axis from minus 0.2 to 15, y-axis from minus 2 to 2, so that you can get a similar graph or better graph yourself. I have entered the function ft equal to 0.2 times 4 cosine 2t plus 2 sine 2t. This is the steady state solution as mentioned in the video, and it is graphed using a rate curve. Right, this is a trigo graph. And then I also input 3t equal to minus 0.8 times exponential of minus t times cosine t plus 2 sine t. This is the transient state solution as mentioned in the video earlier, and the graph is a blue graph like this. And notice that while the steady state will oscillate forever, the transient state, you look at it vibration, it's almost zero after 7 seconds, right? Almost zero after 7 seconds. So what is the final solution? The final solution, let's call this y here, is a sum of these two solutions, steady state and transient state solution. So y equal to ft, okay, plus 3t. Then you see the final current, which is in black. Okay, is in the black or blue here. So I still have the two color here. It's a dark blue here. So you notice that the final current is a sum of these two. All right. So it is equal to this one, right? So this one is actually the final current. Okay. You see the final current eventually is same as the steady state solution. Okay. So if I get rid of the final current and see that, okay, final current and the steady state solution almost match. Okay, go back and see final current here, y equal to ft, okay, plus gt here.